Hi students, today we'll be learning how to graph parabolas by finding roots, or the x-intercepts of the equation. Let's go ahead and start with a warm-up. Make sure you write these two boxes in your notebook. Normal form, y equals ax squared plus bx plus c, and the vertex form, y equals a times the quantity x minus h squared plus k. Pause the screen and go ahead and complete these jiffy graphs right here. Now that you've paused the screen, go ahead and check your work with the work that I'll do now. Y equals x squared. This starts at the vertex, starts at the origin, and this is an upward U. It's not really skinny and it's not really wide, it's just the most basic parabola that we can graph. And I'm going to label this as number 1. Number 2, y equals negative 3x squared. The negative makes the parabola flip upside down. The 3 makes the parabola really skinny. The bigger the number here, the skinnier the graph. So this is going down and it's really skinny. And this is number 2. Number 3, x squared plus 3. This constant, 3 at the end, is a vertical shift that moves it up on the y-axis. If you look at our vertex form, we can see that the k value here is 3. The k value means that it's a vertical shift. So we go up to 3, you can estimate where that is, and it's an upward parabola. This is number 3. Number 4, so this is a new one. This is based on the vertex form here. So we can see that there's no k value. That over here, if there was anything, we can put a plus 0. So there is no vertical shift. However, if you look at the number 3 right here, this lines up with the h, which is a horizontal shift. If we write this out, this is a times x minus h squared plus k. So you can see that the h value is 3. This means there's a horizontal shift. In our formula, it's a negative 3. In our actual equation, we have a positive 3. This is a horizontal shift 3 places to the left. This moves the vertex 3 places to the left. And this is an upward parabola. So this is our graph for number 4. And number 5, same thing here. So we can see that in this case there's a vertical shift of 4 and a horizontal shift of 2. So as we start from the origin, a vertical shift of 4. We're going up 4 on the y-axis, and we're going right 2. This moves the vertex to this point. If you want to write that out, just double check that. So the vertex is at the point 2, comma 4. So again, the vertical shift was 4, so I went up 4 on the y-axis, and a horizontal shift to the right 2. I do the opposite of this negative. I can do my parabola up here now using this vertex. And this is a parabola for number 5. Okay, let's go ahead and start our lesson for today. As a review, here are the methods we've learned for graphing a parabola. The first thing we learned was to build an XY table. So this is how we started, and we chose values -2, -1, 0, 1, and 2. We plugged them into our equation, got all the y values, and plotted those points. We learned that a few days ago. The second method we learned was to graph using the axis of symmetry and the vertex, and then to choose one point. So we learned that the formula for the axis of symmetry is x equals -b over 2a. This is axis of symmetry. And then to find the vertex, we knew that this was a point, an x comma y point. And we just plugged in our x value into the equation to get the y value. After that, we chose one point, plugged it in to get the final shape of the parabola. Today we'll be working on this one, number 3. This will be our brand new concept for today. We're going to learn how to graph by using the axis of symmetry and vertex, and also by finding the roots. What this will look like, so we'll be able to find the vertex. So say we find the vertex is down here. Today we're learning how to find the roots, or the x-intercepts. I want to know where the parabola touches on the x-axis. These 2 points right here. These are called the roots. Or you can call these the x-intercepts. The nice thing about these x-intercepts is the y value is 0. It's always 0. Any point along this x-axis, the y value is always 0. We want to find what this x value is. Okay, let's begin with a problem. Here's the equation, y equals x squared plus 4x minus 12. So again, today we're going to graph by using the axis of symmetry and the vertex and finding the roots. We won't be using an xy table anymore to graph. So I'm going to start by finding the axis of symmetry. The equation is x equals negative b over 2a. Looking at my equation here, I see that a is 1, b is 4, and c is negative 12. Plugging those in, I get negative 4 on top over 2 times 1. Negative 4 divided by 2 is negative 2. So I got that my axis of symmetry is at x equals negative 2. As I go over to my graph, I can find negative 2 here and draw my axis of symmetry through negative 2. I'm going to do that by doing a dashed line going through negative 2. This just shows that it's an imaginary line, the axis of symmetry going through negative 2. And I'm going to label this axis of symmetry at x equals negative 2. Okay, now let me find the vertex so that I can place it on the axis of symmetry. So from here, I'll start my notes down here. I need to find the xy point that's on this axis of symmetry. To do that, I simply need to plug in negative 2 into the equation. So from here, I get y equals negative 2 squared plus 4 times negative 2 minus 12. Evaluating, negative 2 squared is negative 2 times negative 2, which is 4. 4 times negative 2 is negative 8, or minus 8, and then the minus 12 at the end. Simplifying, 4 minus 8 is negative 12. Negative 12 minus 12 is negative 24. So finally, I found that my vertex is at the point negative 2, negative 24. And now I'm going to place that point on my graph. From here, I'll go by 2, so this is negative 2, negative 4, negative 6, negative 8, negative 10, 12, 14, 16, 18, 20, 22, way down here at negative 24. So there's my vertex. Okay, from here, now I need to find the 2 points on the x-axis where it crosses. So maybe those points are right here and here. They could be, or they can be anywhere along this x-axis. To find exactly where those points are, like I said before, the y value at the x-intercept is always 0. So with y equal to 0, for my x-intercepts, I'm going to write 0 equals x squared plus 4x minus 12. This is what we worked on last chapter with solving a quadratic equation that's equal to 0. So from here, using the box and the x, or factoring in your head, I end up getting 2 sets of parentheses, an x and an x. To get 12, that's 2 times 6. I need a plus 6 and a minus 2. You can double check that work by doing the box and the x. Using the zero product property, I have x minus 2 equals 0, or x plus 6 equals 0. Add 2 to both sides in this one, so you get x equals 2, minus 6 on both sides in this one, you get x equals negative 6. These are the 2 x-intercepts that I can place along this. To write the coordinates for those points, you can write this as the x value of 2, the y value of 0, x value of -6, y value of 0. So go ahead and place these points on your graph. So x equals 2 is right here, and x equals -6. It's 1, 2, 3, 4, 5, 6. So now I can connect my points to make the parabola. As you notice, the axis of symmetry goes right through the vertex, and it shows that these points on the x-intercept reflect or mirror each other. They're the same distance away from the axis of symmetry. This is our lesson for today. You guys can go ahead and try this equation right here by graphing the axis of symmetry and vertex and finding the roots by factoring. Go ahead and do that. I'll see you guys in class tomorrow.